I think. Um, so can you see the slide? Can you see the slide?
Yes, ma'am. Yes, ma'am.
Okay. Okay. So,
QKD architecture.
so now I'll be talking about the different QKD protocols and you know how we are actually execute. So what exactly we mean by QKD protocol is we'll discuss now. So what should be the you know the messages after the so the QKD protocol execution itself involves lot of optical communication devices. um, After that, the outcome here is a partially correlated data stream, and from that partially correlated data stream we will be filtering out the data. So from raw key, I'm getting sifted key. Sifting depends upon the kind of protocol. From there, I will be estimating the error and we'll be doing the error correction. This quantum error correction is not the quantum computing's error correction. Okay. So this is a classical error correction technique applied to obtain symmetric encryption keys at both the sides. And after that, we will be analyzing the leakages. After analyzing, we will be reducing again the key based on how much leakage has happened, and then we will be getting the final key. The security framework of this entire thing is a composable framework, so that I can use it for any security applications. So you cannot give a new protocol. Okay, so after maybe you are proposing a protocol, it has to be rigorously and thoroughly evaluated from a quantum information perspective, at that how much leakages it can contribute to, and thereafter whether that model fits into a composable framework, security framework. Okay, so then we have the keys. So a QKD protocol again is of two types. Is the prepare and measure and entanglement based. Last time I had shown you the setup of an entanglement based QKD protocol or setup, and where you have a sender. Okay, let me just go to that slide. And here, of course, is detection based. Again, just like quantum hardware has different hardware technologies to realize a qubit. Similarly, we also have different ways, or again it's a photonic communication, but again a different way of representing the qubit in the quantum as well as a classical, but the property we are using in the classical is quantum in nature. So here we are using different quadratures of electromagnetic field, and here we are using single photons. So this is a slide which I had shown you in the last presentation. Here the Charlie will be having so in entanglement based communication it is of a higher security, but it is limited by distance. I had mentioned fiber based QKD about 100 150, again depending upon how you're measuring it and what is the protocol. Twin field kind of a protocol goes about 200 kilometer, 160 to 200 kilometer. Again I would say a academic academic limits or academic values of the key parameters of a QKD varies with that of a commercial. A commercial may it is very less because it's a cryptographic device and it has lot of other things which it has to take into account. Whereas in academic setup you have the experimental setups with calibrated electronics around you. Okay, so that is the reason it is challenging to build one, and you realize that it has to be done indigenously so that you can have a technology control over it. The detectors are the Achilles heel. I'll keep mentioning that because it's very critical, and we still do not have an Indian solution. In entanglement based setup, you have a Charlie who will generate the state and send it to Alice and Bob. Alice and Bob are two receivers who will be doing Bell measurement or Bell state, distinguishing the Bell states or measuring the entangled states. And there will be a QKD or quantum keys shared between Alice and Bob. Charlie is only the sender. Now, since it is an entanglement based setup, it doesn't really matter from where you are buying the source. It can be trusted or it can be non-trusted. Okay, because it is the experimental parameters you will be doing at the Alice and Bob side, such as bell measurement tests. If there is a violation, you will ensure that the transmit or whoever is the Charlie is not cheating you. Okay, so you do not, so you reduce your dependency on the device, and that is where measurement device independent QKD protocols come into picture. Because it is dependent on entanglement, they do not have very large topology, large distances. They cannot cover hundreds of kilometers. Again, of course, it depends upon the level. If it is in the ground or you're taking it into a higher altitude, then the noise will be less. Maybe the distance will be higher, but usually that is the range. And in measurement device independent kind of a QKD, you will either be trusting the detectors or you will be trusting the source. Okay, so there is no protocol where you trust nothing and you get something valuable. So now, prepare and measure would mean that you are preparing and sending it to the other party and you are measuring it. That is how Macan Network, CDOT, QNU Labs, all their QKD protocols, even what we are building from our fintech project, it is a prepare and measure protocol, which we will talk shortly. We are also working and building entanglement based. At the moment, the work is going on in lab to build BBM 92. After having done the validation, we will be doing a QKD application. So, the entanglement based setup, as I told you again, Charlie separate transmitter, two receiver, Alice and Bob. And in prepare and measure, one transmitter and one receiver 100 kilometers apart. So BB84 protocol, I don't want to spend more time here because I had already explained it to you. Just a quick recapitulation. You have you do need random numbers. Now, many of the times I have been told that is a true random number a requirement for QKD, a PQC or not? Well, in when I was working, when I since I go through the theoretical analysis, I do consider the random numbers from the Alice's side coming from a true random number. That means there should not be a repetition. There is no question of any seed. So definitely it is not a PRNG. It has to be a TRNG based. And a quantum random number generator is nothing but a hardware random number generator based on quantum mechanics. So here you have these random numbers at the Alice's side through which she decides which states to send. Only she has the information and she's not going to share it with Bob. Alice then makes the physical qubits from this information where, if you remember, I asked you to, closely note that I had designated ket 0 as logic 0 and ket plus also as logic 0. So in these two basis states, each basis state has a logic 0, logic 1. Hmm. So again, two basis states is rectilinear basis, as you can see here, and diagonal basis. Okay, so there is, suppose the horizontal is 0, vertical is 1, 45-degree is 0, and 135-degree is 1. So, okay, so here it is vice versa. Here 135 is considered as 0. So Alice sends these number randomly, and which basis she also uses a random number to generate to randomly choose between the two bases. So this is the output looks like. Then qubits reaching Bob, some of them will change because of the atmospheric or attenuation or ambient criteria conditions. These are very fragile, so they will change. And then Bob will bits random basis. Huh? Then Bob will be doing. Remember, I mentioned that there will be no prior information, so Bob will be randomly changing the basis states. He will be randomly opening the different sides of the boxes or doing random measurements. And based on that, he will also be getting 0 and 1. But he will also know that he got 1 from which basis. That information he has. So then Bob tells Alice the basis that he used, diagonal or rectilinear basis for his measurement. And Bob tells him which one is correct and which one he should drop. You'll see that, I mean, either the bit has flipped or something like that. But if there is a mismatch, then they will drop it. Okay, and then we have Alice tells Bob which bits to keep. Okay, fine, and then they get the secret sifted key accordingly. So please do pay attention to what I'm saying. But sometimes there may be typos because these are also done by my students. So I hope things are going as per I'm speaking. Okay, I have also, so this is also mentioned here, which logic states has been taken from different bases. So now we'll not spend much time. This should be very clear. Now, BB84 is also, as you can see, Alice is in one side, Bob is on the other side. It is prepare and measure. DPS QKD protocol, it is one of the protocols which DOT has standards against which that means that we Indian players are making these QKD protocols. So you will find more information in this paper. So what they do, so you have a quantum state generator, you have an encoder, you have an attenuator. Hmm? So this is what a quantum transmitter looks like, and you also have a random number generator, RNG. So this is a quantum transmitter, and based on since it's a fiber communication, here the information is encoded not in polarization but in phase. Earlier, it was in polarization. Here it is in phase, and there is a particular reason why we are using phase encoding for fiber communication and polarization encoding for free space communication. And I think we must be having physics teachers here who will also come to my defense. I mean, because again, I want them to be as neat and less distortion, and they are very fragile, and the environment can perturb any of their degrees of freedom. So I will be using that degree of freedom which is more compatible and um, uh, less subject to any noise in the during propagation. So you have a DLI. Last presentation, I spent some time on an interferometer. An interferometer is also part of your course. So here we have, and whenever there is an interferometer, most of the time we are working on phase. I think there is also, a single photon interferometer experiment based on polarization, what we do. And there we have the PBS and mirrors and and polarized states. So here, this is a phase encoded setup, and we have a delay line interferometer. It delays the signal uh, by half of the repetition rate. So if you have 1 nanosecond, 1 gigahertz, then you have 1 nanosecond. So it will actually delay you by 1 nanosecond duration. The idea is to overlap the consecutive pulses. SPD is it is not spontaneous parametric, down and then 1 and 2. It is actually single photon detector 1 and single photon detector 2. One detects whatever one will detect. I will consider it as logic 0, and whatever one SPD2 will detect, I will consider it as logic 1. Hmm? So again, so I will be getting a binary sequence at the output. um, so here again, you have the laser at the transmitter. You have a binary number that goes into the phase encoding using the phase modulator based on the random numbers. You attenuate a single to single photon regime, and then you send it. You have a DLI, which is a decoder, and you have a which is doing combined DLI and SPD. It works as a measurement and detection unit. Then you have a series of binary numbers, partially correlated binary numbers. So that is a part of the raw key, which we had discussed. All this is actually raw key. So whatever is after Rocky, I'm not discussing that in too much detail, because all of them again is a different subject and they play a very critical role, and they are all are classical in nature. Okay, so there's something again which it's on counterfactual QKD, which means quantum interference enables the counterfactual transmission of information, whereby the transmitted bits, very important, the transmitted bits involve no particles traveling through the channel. So this is something which is again a counterintuitive case, and I don't want to create too many controversies here. So let us not get too much detail into this. But this is, so what I'm trying to say is there are different ways of doing a quantum communication. So counterfactual QKD is also one of the areas. And then you have quantum secure. Okay, so it is not here. So quantum secure direct QSDC say communication. And I think now you are able to get an idea why it is so complex and challenging to come out with standards also, because it is continuously evolving. Now the challenge here again from the industry perspective is you have a continuously developing quantum computer. Okay, and quantum computer is going to crack the codes. So there is a necessity, a requirement from the national interests perspective to transition or adopt quantum measures, quantum safe measures. Now when I'm talking about quantum communication, there is no standard protocols, and there is no standard way of doing a QKD. We are taking one of them and we are doing it. Okay, and there are so many key ingredients to it which I'm not able to mention right now, but each and every QKD, if you take, opens up a huge learning journey. So this is a challenge, and this is why we also say that if there is a standardization and testing center, it has to continuously evolve and adopt, and it has to be flexible, and that has to support innovation. And the reason I'm saying this here is all this can happen only with skilled manpower, trained manpower on hardware and software. So this is the entire objective behind this. This is the schematic of a B92 QKD. So this is another QKD I'm discussing here. So what we do here is, earlier you had seen BB84, where you had 4 states, right? So these people, they met again and they said, "Okay, fine. I mean, using non-orthogonal principle, no, we cannot clone non-orthogonal states. I can use that principle and I can decrease the number of states. So instead of 4, you will see there is one each from the 2 basis states, ket plus and ket 0. So the thing is, if ket plus 0 is sent, you will be getting it detected at with the ket 1. If ket 0 is sent, then you will get it with ket minus. So both belong to different basis states. Now B92 QKD, B92, okay, where did it go? B92 QKD also, you will see encoding 0 and pi. Okay, so they are again highly non-orthogonal at these particular 2 phases. I'm not using the word non-orthogonal states here. It's a weak coherent source, not a true single photon source. I'm using the word, it is maximally non-orthogonal. Okay, so all these nomenclatures, the way I'm addressing it is very important when I'm looking at it from the theoretical security perspective. So in B92, we are using polarization states. Why? Because we are doing a free space QKD here. Hmm. So in free space QKD, I had already mentioned that we use polarization. So these are the 2 states. Well, I'm using 4, but at one side, it's only 2 of them. That reduces my form factor, that reduces my load, and reduces the weight. Okay, so all that is essential for an aerial application, which I will talk in the next slides. And again, you can see in the transmitter, you have a quantum source generator, you have a quantum encoder, there is a compute engine and communication module, because there is a lot of classical communication which is happening between them. So this is a quantum channel and this is a classical channel. Now, this is how the B92 setup looks like. Again, if you're visiting our lab, then we'll be able to show you the optical gadgets here. Of course, this is 34 centimeter, but the first QKD BB84 was also 30 centimeter, and today we have QKD over thousands of kilometers using satellite and terrestrial using trusted nodes. So I would not use the word repeater with DPS. I will be using the word trusted node. Okay, so there is a protocol on how we propagate the secret from 1 to say 100 to say 500 kilometer using hopping, using trusted nodes, and you will see this as one of the delivery in National Quantum Mission in the communication vertical. So here it's again an experimental setup. It has a lesser rate as you can see, but that is also why, because it has dependency on GPS. Once the signals, the two systems are kilometers apart, you will have to do the communication to the precision of nanosecond and picosecond. So such precision and with availability of time synchronization at these two systems, we use FPGAs as compute devices, and I also think that familiarity with VLSI and FPGA is also a prerequisite in any of the quantum technology hardware, whether it be communication, computing, sensing. All these require codings and algorithms to be implemented in these. One of the reason is also because of the time precision and real time system. This is a final key which I'm getting. You can see the rate is high, but still the output is very low. It is in seconds. So just to tell you how this, in one of our workshop, we actually did it live. We showed it to the participants in the ground floor from the lab. What we did a test case. So all in 1 second, we only send logic 0. Remember, I told you that logic 0 is ket plus state. So I generated 45-degree polarized states and I sent them over the channel. So if I'm sending logic 0, I should be getting logic 0. So after my encoding and decoding, that's what I'm getting, the highest. So it is in logic and highest in ket 1, which is my logic 0, and least but not 0 in ket minus, which is my logic 1. Similarly, if I'm sending a logic 1 state, after the decoding, it should give me a logic 1 state, which is my ket minus state. Okay. So you can see the encoding and decoding of a QKD. So it is a real system. We are generating the quantum state. It is moving through space for a distance which is at present 30 centimeter. It is getting detected on the other side. The decoding is done. It is the same logic which I'm sending. Now, what happens if I'm sending zeros and ones, in such a state? So there again, if I'm seeing that I'm getting 50% of my detections are in logic 0 and 50% of my detections are logic 1, where they are represented by different basis states. So it's, I think, last few slides, but this topic is very, very important. Now somebody from the classical world, the way to attack of a quantum optical channel can be through fiber tapping, or it's a different mechanism, right? Or in free space communication, it's difficult even to think that how the tapping or how it happens. Maybe I would like to get educated from you. But in the quantum world, we give all the powers of physics to the adversary. Anything which I am not able to have in this era, I will be always calculating my present risk with respect to the information leakages which can happen if there is a quantum adversary lab with quantum memory, with quantum computer, with quantum repeater. So we categorize the attacks. Also, please remember, I told you the quantum channel is insecure, classical channel is secure. It's very important to use the right words here because it's quite contrary. The quantum channel is insecure. So one can attack, and I have to detect that attack. Okay. So this is incoherent attack, collective attack, and quantum attack. These are the three attacks. And to also tell you that a lot of people have been working theoretically and trying to simulate these attacks. And some of the attacks, very few of them, can be practically possible. Now, using a quantum hacking system. Now, let us see what it means. So, whatever attacks you will be hearing, intercept and resend, which means I'm intercepting a communication, copying it, creating that state, and resending it. Okay, intercept and resend attack. Then we have beams splitter attack. Hmm? So these are all the optical gadgets. Okay, and then so it's very important to understand the physics and maths of these important optical gadgets. Primarily beam splitter. It should be studied in detail. Okay, it will involve some part of optics, quantum optics, but it is if you would want to do a theoretical research or come up with a attack on any of the communication protocols using these optical gadgets. So beam splitter attack is the is the minimum attack which or the easy attack which a quantum attacker can do. Photon number splitting attack, it's very interesting. So in classical, you are sending pulses, no, and each pulse has millions of photons. But in quantum, you have anti-bunched photons, which is you're having just one photon in each pulse. So if you're using such a source which has a finite probability of more than one photons in a pulse, then same information is available with the other pulse, with the other photon. So photon number splitting means an adversary can look at the number of photons. If they are more than one, they will pick one. And such attacks are not detectable. So that is the reason we have to calculate the risk. Remember when I played with you, right? That game when with the balls and all, then I had shown you some cases where the detector, where the Bob is not able to detect. Okay. But Eve is still acting on it. So there will always be a threshold error that which have to take. So PNS is a very dangerous attack because it is not detectable. And it is this for this reason that we have to ensure that we are only working with single photon states. But however, all the QKDs which are there in Indian market right now are based on weak coherent source, which follows a Poisson distribution, which means there is a finite probability of having one or two or three photons together. Okay, so we usually work with mean photon number equal to zero point 0.1. And if you see the Poisson distribution for mean photon number 0.1, there is a finite chance of having multiphotons. So that is the reason when you talk about protocols, BS attack and PNS attack are very important. Then there is general. So what happens is you have Eve has a probe and they attach each qubit to the probe, and then you separately measure the states. So you are separately measuring the photons. This is what we are doing at the Bob also, as you can see. So this is something which can be experimented. Then you have collective attack. In this, you need a quantum computer. In this attack, Eve can entangle her system similar to the individual attack, but she performs a global measurement. See, it is an individual measurement, but this is a global measurement. And this will give her advantage to explore the correlations whenever they are announcing the states of the qubits or basis states. So she can take advantage from that. Next, we have coherent attack. You need a huge quantum memory and you need a huge quantum computer. Okay, so this is the most general and powerful attack. Eve will entangle her system with a probe of huge dimension, which similar to all the transmitted photons, and it is extremely difficult to establish security. At the moment, BB84 with single photon is the only candidate. And that is the reason most of the security protocols are woven around the BB84 to ensure security. Sadly, many of the players in the country still believe that going longer distances is the is an achievement. But in quantum, it is quite the contrary. We understand distance is a requirement, but security is the thing why we are doing the communication. So please take into account, and if you do any type of a propose any type of a new QKD protocol, there's a lot of security measures and security analysis that comes along with it with respect to a quantum adversary. Now, if you look at the future, why should I say future? Maybe I should say near future, because there are already alliances, world alliances, which are working on quantum internet or interlinking different quantum platforms for an integrated application. So as you can see, you have satellite QKD here, you have aerial QKD, you have drone aerial communication, high altitude platforms here. Then you have terrestrial QKD platforms, and they can be direct free space communication as well. So all this plays a very important role. What we are talking about is ground stations and satellite, but if you have to link them all together, then we need to develop different modules or in between layers. And one such thing I have picked it up for the present project is on aerial quantum communication. So if you look at the national scenario, you have free space QKD, which RRI, PRL, even CDAC has jointly done a project with PRL on free space and fiber communication. Free space again RRI, and you can see hybrid photon based free space QKD test bed here. In DRDO has also worked on it. Now look at the movable satellite QKD. Okay, in satellite, okay, so satellite QKD I have not covered here, but anyway, ISRO is also working on that. But a QKD would involve many different elements which has to be covered. It's not just sending the bit from here to there with several assumptions and not considering all the challenges together. As I said again, it is all engineering challenge. Okay, so in aerial we are doing a QKD using a movable platform or a mobile platform with between two drones, or drone to ground, and ground stations are movable. So this will involve quantum data transfer post the pointing acquisition tracking is done. So there is also some innovation which is involved here, and similar work are done in China and US. And recently there was a paper in May 2025, which is actually a good review for QKD using movable platforms. So these are the two test cases we are trying. So at present, this case is in the lab, and we had shown you the glimpse of it. And the payloads, we are developing the payloads for drone to drone. The testing has already been done. Now, as I told you that this involves, again, not only the transmissions, but before the transmission, we have to ensure that the transmission is done properly. For that, we need pointing, acquisition, and tracking. Okay, so we are working with our industry partners. I don't want to get into details here, but it's a lot of interesting work. And once we ensure that it is position is locked, we are getting the right position, then the quantum communication happens. So these are some of the activities we are working with Sagar Defense Engineering team, and we are also validating whether we are subjecting it to different mechanical vibrations and seeing how and looking at the performance. So we have given a lot of demonstrations, and we also have facilitated visits to our labs by different engineering colleges. We also participated in the National Science Day in our organization. This is the box I was talking about. This is the classical box, and the quantum box, I think, is in his hand. We also have a lot of visits from scientific community, discussing about the technical challenges, and which is, I think, you'll be also having. And this is the summary. This we also we had I cannot say demonstrated because it's still in the building, but yes, we got an opportunity to showcase what we are doing in Aero India, held in February 2025. And this is the team, and thank you again for your patience. And now I'll be happy to take some questions. Oh, I hope I have not put you to sleep again. Okay, yeah, I can see a thumbs up sign, which means yes, I am audible. Thank you, Dr. Shilpa. Thank you, Satish ji. Thank you. Yeah, so I'm open to questions, sir. Thank you, madam. Thank you. So I should open up the chat, and if you could share the answers. Classical leakage. So classical leakage means that if we are, for example, I'm doing an error correction, so I'm sharing some parity information with them. So any communication leakage, any leakage which is happening because of the classical communication process or because of the devices within the transmitter and the receiver can be, can be represented by this word classical leakage, but particularly during communication. Can QKD be in? Of course, that's what I said. When we are doing the theoretical analysis of a QKD, I'm considering the random numbers to be coming from something which is forward secure or which is can be truly random. Now, I know that it's difficult to say whether something is random or not, but in quantum mechanics, we do have these postulates, we do have the rules, and when we generate randomness out of that, and that is the reason we say we can certify the randomness if it is in the quantum, which cannot be done in the classical. Okay. So QRNG, yes, we need it for QKD. Absolutely, yes, we need it for QKD. Thank you, Saloni, madam. Yeah, and have linked it. Yes, yes. It has been done before, yeah. I mean, it has been any benefits of using photons from sun's ray, okay, directly for QKD in satellite communication. I don't know. I don't have an answer to that. Of course, we can use classical light, but the property on which I am doing my encoding and decoding has to be a quantum property, unless otherwise it will not obey the rules of the no cloning theorem and all. So they do have to follow the quantum principles. No, the thought is good actually, and this is not the first time I'm hearing this question. So you are second, so I know that. And there are some papers also, where people are exploring this part. But yes, whatever it is, but then and the continuous variable which I discussed is a classical light, and it's a beautiful QKD. I mean, you get higher throughputs, you get it easily off the shelf, and but when you're encoding and decoding, it has to be on the quantum principles or quantum property. It has to be on a quantum property. That's all. Yes, yes. QKD protocols are implemented in 5G. Why? Because I was working on a note for some activities in the ministry where I got this opportunity to explore or do a literature review of QKD in 5G. And if you are interested, I'm so happy we can also work with you and do a small POC on QKD with 5G or QKD with 6G, because good news for me is QKD remains the same. It's all about integration with these technologies and demonstrating an application. Bell state 1 by square root of 2 is maximally entangled states. Yes, there is an advantage for maximally entangled states, and when we consider entangled states, they may not be as pure, they may be not maximally entangled. So that is another actually line of area where how this impacts the communication fidelities. Those things are mentioned, but I think it is worth looking at it as well. Here, I assume that it is maximally entangled, but whenever I'm doing my measurements and all, it need not be, because the way we are capturing it, if there is a, if I lack in precision, then there is chances that I'm not getting maximally entangled state. I'm getting entangled state, but not maximally entangled. So please, there are very good research papers on maximally entangled states, and they are theoretical in nature, but I think it's you may would want to look at it. Uh, Madam, terminator would mean I do not get it actually. I am sorry, I'm not able to understand what is terminator.
No, ma'am, it's just a spam question.
Oh, okay.
Please ask relevant question relevant to the topic that is discussed in this particular session.
Okay, but these are interesting questions. It's just that I do not have an answer. So I learned Eckert 91 is the best, and you chose P92. Yes, I know there was some discussions on which protocol to use for 29. Eckert 91 is an entanglement also, no? Based BBM 92 and Eckert 91 was the I was trying to figure out which one. Of course, we have to look into the complexity of of the optical design and lesser components and stability. So all that was our selection criterias. Best communication protocol for implementation in communication technologies. If you mean QKD protocol, so since I'm coming from industry, I will always ask the user, what do you want? Do you want a high throughput? What is your distance? So based on that, I will suggest what is the right protocol for you. Full stack communication. So actually, you have quantum QKD. A full stack would mean right from the application, taking it from the physical plane to the application layer. And lot of papers and people have actually implemented this when you are doing a network using. So this is very much their full stack communication network is there. People have implemented, and hopefully India should be implementing it soon via this National Quantum Mission. Free space, again, it depends upon what is your height from the sea level, and what is the atmospheric conditions you are looking into that can limit your distance, that can also increase your distance. That's the reason higher altitude platforms are chosen. Satellite QKD is there. People have implemented, people are implementing, but the rate is very low. So, and the duration is also very less. So that is the reason aerial platforms will be useful compared to a satellite. But of course, satellite covers thousands of kilometers. So it is something which will happen very soon in a usable manner. Fiber 150 kilometer, 100 kilometer. Again, there are techniques to increase the signal strength, and then you can take it till at least 150 kilometer. Twin field protocol. It's a breakthrough protocol. It can support 200 kilometer. Free space, as I told you, depends how you are doing it. So I think, sir, I have tried to answer most of the questions. If there is something more, I can, take it sometime later also.
Yeah, sure, ma'am. Sure. Thank you so much.
Thank you, sir.
Yeah, it was actually, we have requested ma'am for the same thing, that an overview and also a lot of questions of how to go about, and what can be various problems and challenges that we can look at, and uh, very different aspects have been covered, apart from covering QT-04, some content which was related to the optics. So thank you so much, ma'am, for the time that you have spared, and ma'am will be there in QT-05 also for some sessions, so we'll be happy to listen and learn. So we will Thank you so much. Especially, ma'am is a teacher, so obviously that is evidently showing here. So thank you, ma'am. So we'll just have a quick time of conclusion. If there are any questions, ma'am has already answered anything. So most of you have requested for the extension time in answering quiz 3. We will give you some time. Most of you were really worried at the beginning that slide number 1 was not moving. So I will request all of you who were worried about the slide, please go back to YouTube, listen to that first 20-25 minutes of what ma'am talked. Right, she had given a big challenge for all of us, especially for Indian students and faculty, and she has actually asked all the faculty members in this group to take it as a challenge and do something. So please listen to that 25 minutes again. I'll be happy if you do that. It'll be great blessing. And I think we should do something. So that's where we are all spending all these efforts. And all the resource persons are sparing their valuable time, canceling meetings for us and being here. So I was running between, I just ran for some important call. Then I came back to be on time here. So you can understand the efforts that we are putting in. And hopefully we will see that we will be this 1,000 people is a big number of 800, 895 or something have taken the quiz. Many are not there on the call. About 300 are there on the call, but 800 are following the videos and the slides. And I keep getting requests on personal WhatsApp, and also in the groups you would have seen that this material is not there, that material. So people are actually following everything, and they are sparing time. I have heard people getting up at 5:30 in the morning to listen to the YouTube videos because there's no other time. So these are the kind of challenges we all have, but there is a big opportunity. That's what I want all of you to take forward. So we have Dr. Shivansh Mishra from IIITDM Jabalpur, who was one of the joint principal coordinator. We have Dr. Mustafizur Rahman, who has come from IBM. He was the resource people. He has taught you so many mathematics aspects. And we have Dr. Anand Raman from NISER, Bhubaneswar, and he has helped us to understand a little bit of how high performance computing and quantum computing can go together and how they can complement one another. It's a big challenging area. I missed the session, but then I'm happy. So I have requested few participants who are actively participating to share few thoughts. Then I'll request the resource people to share a few thoughts about the course, and we will thank the resource people, and then we'll conclude. So we'll start with Rajesh Chaurasia ji. He works with an industry, spares every afternoon time. He places a question every day on the WhatsApp group. So I'll request him to share a few thoughts about the course. He has attended all the 3 courses. This is the 3rd course we are concluding today. So Rajesh ji, if you're there, can you share? Yeah, you can turn on your video. We have not seen you. We only interacted over phone. So if it's possible, you can turn on. Yeah, please go ahead.
First of all, I congratulate all the people who are collaborating over here, whether it is teacher or industry people or a participant from various institutes. I appreciate the kind of enthusiasm everybody is focusing on this critical technology, which is of very immense need for in respect to security aspect. It's not just about security; it's something a new paradigm of computing which we should be learning. It's not just about being aware. It's also about contributing in that, and definitely the way faculty people and industry experts have provided know-how with some case studies and lectures. It is very good, and I found this course very uh, economical also. Knowledge usually sometimes has a price tag attached to it, but over here a lot of things were taught in very economical way, and this is the best way to disseminate critical knowledge to more wide people. And I appreciate him and every person like participants as well as faculty as well as the organizers for all the incredible help for managing and making the smooth conduct of this QT program successfully. In so far, QT1, QT2, and QT3, everything has gone fine. But I have one suggestion that at the last QT week of every QT, if in coming QTs, if we can have a deliverable from the participants, like some maybe form a group of people who can apply that knowledge that we have gained and show some deliverable. I don't know how practical it could be, but it would be the best thing to share our grasp of the concept, because theoretical knowledge is something that we have will help, but practicality should come from that also. If we can apply a concept and what is its uh, implementation, that would be the best thing, because that knowledge will go forward, and who knows, some within some of us, we write some good algorithm, we give a new insight that can help others and will help our country. So I wish if we can have some practicality attached to this QT programs in coming forward. No, because the so far we have done the groundwork, and now everything should be I think if we can do some practicality of those concepts, so that will be very helpful. So that is what I wanted to convey. Thank you.
Thank you, Rajesh ji, and thank you for the active participant in the group also, and also while asking questions. And I am sure I was always guessing that you are a senior person, and I was right. Thank you so much for joining and sharing your thoughts. We have a young student who is doing her post graduation, Saloni Vishwakarma. So yeah, she will share a few thoughts on the course. Saloni, you can turn on your video if it's possible. Or you can share, no problem.
So is I'm audible?
Yeah, please go ahead.
I can't show my face as I'm not well. So
Okay, please go ahead.
first of all, to thank you to all the organizers and faculty of MNIT Jaipur for creating such a rich and structured journey of quantum. Before this program, I spent a lot of time searching for a college or a course that actually taught quantum technologies in a structured way, but I couldn't find one that matched my needs. But then I came across one of my professor gave me the brochure of MNIT Jaipur sessions, and I got the perfect answer. So I'm really grateful that learning about such a great technology through these sessions. And I'm very grateful that I am getting on the sessions and on the information, very crucial information through the experienced IBM experts and on 3 to 4 big academics, and you know they just taught many of number of people's a good technology on such a small level. And I really pray, and I like I cannot express my feelings. This is such a, when I don't know about quantum and when I came across to the quantum, I also wrote the research paper. It really helps me a lot in my academics. And also I wanted to do something in quantum and I came across this. So this is really a proud thing for my country that this technology is coming, and such a experts coming and teaching about the quantum technologies and its information. As I said, a very crucial informations about quantum, it is such a big thing. So I'm really grateful. Thank you so much, sir, and thank you so much to all the organizers.
Thank you, Saloni. Yeah, thank you for many of the speakers were there. Yeah, Professor Asha VKR is there. Yeah, ma'am, you can share.
Yes, sir. Good afternoon, one and all present here. I'm Asha Vikyar from the Department of ECE, SEA College of Engineering and Technology, Bangalore. We are around 5 people who have started off this QT series of FDP program. We started off with 5 members, but we have ended up with only 2 members actively participating. So it gives an immense pleasure to express my sincere appreciation for the enriching learning experience provided to the 3-part series of FDB program on quantum technologies and applications. So I have been asked to give a appreciation note regarding this. I would extend my heartfelt gratitude to all the distinguished speakers and resource persons across the sessions who have played a crucial role in helping me, especially despite not having a prior background in quantum computing and making me understand the complex of the concept with clarity and with lot of confidence. I would also extend my special thanks to all the organizing team who ensured flawless coordination and content-rich sessions. Special thanks to Emmanuel Sir, Mahipal Jadeja Sir, Dev Prakash Samajdar, Rajiv Arya, Sri Hari Rao Sir, Sanjeev Manhar, Gaurav Trivedi sir. They are all from different IITs and MNITs and NITs. Your collective effort, dedication, and vision have truly made this FTP series a valuable and empowering experience, sir. At the start of this FDP, when I heard about quantum technologies and application, what is this? Is it with respect to physics that we are going to learn or with respect to the computing programming that we are going to learn? That was the main question that I had in my mind. Then at the start, I really was having some clarity given by the eminent speakers whom I have not yet mentioned, especially Dr. L. Venkata Subramaniam sir from IBM. He was a very eminent and wonderful person who gave like a small kid. I was listening to him, though I have around 20 years of experience in teaching electronics and communication. I was not at all a good student when I was a student, but because of him, I was very much vigilant on the class. I was very active. I was listening to him in the WebEx, though I was complaining to every person I would get in the group telling WebEx is very, time consuming and, battery consuming, network consuming. I had very cribby nature. I was very cribbing with respect to that. But there was another option of YouTube playlists which were circulated and it was very much helpful for us. So coming back to QT1 where I learned about quantum physics and computing where I did not have any knowledge about it. I learned about qubits, superposition, entanglement, the circuits. I learned about the simulators, Quiskit. I didn't know how to pronounce the word Quiskit. And I bet I could not even pronounce Penny Lane. Okay, I don't know whether it is the correct pronunciation or not. And talking about basic quantum programming FTP, which was an eye opener. I literally didn't had any knowledge about the programming background. I did not have any programming background. I did not have any knowledge in the algorithms, the quantum algorithms, so many things which were unaware of. Though it was much about mathematics, much about physics, I could not know anything about it, but which happened from for a tenure of almost 3 months, if I'm not wrong. Okay, I'm really thankful to one and all for laying this strong foundation for many like me who are much not aware about things. Okay, so thank you for giving me an opportunity to give an appreciation note. Thank you, Emmanuel sir. And I would request everyone to use this opportunity, not just, attend, get the certificate. And if at all anyone has not attended regularly the WebEx sessions, all the videos are almost there in the playlist. So kindly go through them and use it uh, in an ample way. And this is my kind suggestion. I wanted to just remind as a faculty, I'm reminding, I'm so sorry if I'm going out of reach. Thank you, sir. Thank you for giving me the opportunity. I'll just on my video. 2 minutes. Yeah, this is me, sir. Am I? I don't know. I'm not able to present myself. That's okay. That's okay. Thank you, Emmanuel, sir. Over to you.
Thank you. Thank you so much. Thank you so much for that. Yeah, we have one international participant with us. Andres, sir, are you there? He's from Peru. Uh, Andres Barbarebaza. Mr. Andres? Okay, maybe there may be some joining issue. That's okay. Yeah. Yeah, I think there are few people whom I know, Avinash ji or Debanshu ji. Anyone would like to share anything before we go out to the speakers? Please raise your hands. Then there's an option for this, and then yeah. Bhavna Bose, we are making you a panelist. Yeah, you can share. Yes, please. You can share.
Hello, good evening, sir.
Yes.
Bhavna Bose here from NMIMS Mukesh Patel School of Tech Management, Mumbai. And I've attended all three sessions, QT1, QT2, QT3, and I'm looking forward. I've already registered for all the other sessions as well. Looking forward to meet everyone offline. Actually, I have just started pursuing PhD in quantum. So when I got introduced to this, I was researching it for about a year, but I will applaud everyone on the depth of the topics, the range of topics which are covered. Because many things, I read up, I couldn't understand, but the way the speakers have been explaining the things is amazing. I mean, in the beginning, the first QT1 session you had mentioned about, I think QT2, that we should teach, then we understand the things better. And that's what I feel is happening. Even I'm getting encouraged to, I've talked to my college that I would like to take a small course for the students because we've not yet introduced it as a course in our curriculum. So that was great, and a very inspiring thing I must say is all of you all are such senior faculty members, even the speakers, and they have taken time out to teach us. So that gives me the thing that okay, I can also find a little time to study. Normally, we always have an excuse of from where will we get the time. So I was very, very inspired by all of you. You all are doing your regular workload, you all are teaching, you're like organizing this thing, and then police her, especially late night also some message will come. I think I mean, I think all the organizers we interact more with sir, but I would like to congratulate the entire team because this is a very well organized FDP, and I've attended many because quantum was a subject where I had to keep attending lot of FDPs to understand it, but this was a very, very good, good luck and keep it up. And I mean, I'm very junior, but I mean, I really, it was a godsend. It needs, it helped me connect to so many people because of this. So thank you very, very much, especially for people who are lost like me. If we really go through the content, it helps us quite a lot. So thank you very much, everyone, the organizers and the speakers for taking their time out, and everyone very patiently, tolerated our doubts, our, so that was very nice. Normally, everyone doesn't have that knack for teaching, but everyone came down to our level. So thank you very much. Thank you, sir.
Thank you, ma'am. Thank you for being active in the group. Yeah, Gurunath ji.
Sir, are you hearing me, sir?
Yes, yes. Please go ahead.
Sir, thank you so much. Even though I am about to move towards home, but you have given me an opportunity. I have given my mobile to my another colleague. That if my name is pronounced, please give me a chance. I am on bike. But sir, now I am daringly entering in a class for teaching quantum computing. Earlier I was hesitate. Actually, to be frank, I am giving those topics like S gate, X gate, then Y gate, Z gate, Edmonds gate, and pi by 8 gate. All are given seminar to the student. So it is your battle. You should look it. But now attending, I was really thankful for MNIT and those speakers who taught that fundamental things, and I have worked out on that. It is without working on that, it is very difficult to follow it. But still, then in Hedemond gate, that we are getting input, but again output we are getting, rather than getting that cat 1 and cat 0, we are getting 1 1, and for that the sir was getting 1 by root 2 times of that cat 0 and cat 1, how it is getting. Still I have to be learned, sir. For that I have to concentrate more, and I am enjoying my class without any hesitation, dealing with student. And few YouTubes are passed to my final year student. They are very much happy. So directly, indirectly, now I am creating interest, and then I will go for that postgraduate. I mean, your diploma postgraduate for fifth QT. Definitely, I'll complete, and hopefully, I may get this certificate. And I will start about, and I will pass this message to my VTU, where 225 colleges are there. You can think for this quantum technology, one of the elective subject in undergraduate, sir. Thank you so much, sir.
Thank you, thank you. That's a great thing. That's in fact JNTU Kakinada had about 200 colleges under them. Yeah, that's where I could interact with Dr. Nindita, and they have done a similar faculty development program, and they invited us, so we were there. And many I'm referring you, Dr. Jaykumar, for many programs he'll be getting invitations. So they are asking me. So I said practical work. So let's look at that. That's something. Thank you so much. Uh, Andres, sir, are you there? Mr. Andres? Yeah, please. No, I think he's not there. Okay. Swapan Kumar Nandi, sir? Yeah, yeah. Please go ahead. Yeah, yeah.
So I catch up in the T2, and mostly, so let me share my video as well. For I'm basically a senior citizen to start with. I first studied quantum mechanics in 1981, and when I admitted into the MSc in physics, and fortunately or unfortunately, I dropped out, and then took an admission into a 3-year BTech course, which was supposed to be after graduation, either in physics or in chemistry. I'm basically a physics honors graduate, and I have more than 35 years of experience in deep understanding about the electronic circuits and software in depth level in the architecture, operating system framework and application development, and many complex application software I have developed for the both international and national. But this is one thing when I joined this QT2 and then in QT3. So there are many things which are being taught. Some of them were creating resonance in me, like statistical mechanics and some aspect of quantum physics and mechanics as well. Now, so this is a good thing that we are going through, and what Dr. Banerjee has said, that we have to take the challenge. And I personally convey I am going to take challenge to contribute to this field reasonably, if not significantly, in the form of startup might be. The first focus would be to provide sharing knowledge in an unambiguous and easy way. So that is very, very important. And that's why I have also written in the chat that apart from syllabus, so it may be value adding to come out with standard teaching materials as an aid to the. So I'm writing this one, repeating this one again here. So, or let's say the syllabus is there, fine, but it may be useful, to my opinion, to come out with the standard teaching materials because this subject is a complex subject. Those who are students today, so they have to teach to the other students. So there is a high chance that there will be a communication gap, little misunderstanding because mostly due to the complexity of the subject. So I had.
So that way, so this is one area I thought need to be think of. And second point is that let's say understanding the physical significance of the mathematics involved, which is very, very crucial. I'm now putting most of my effort to understand physical meaning of the mathematics. I am now in that stage. And secondly, that lastly, that there are challenges, of course, that classical quantum integration, that encoding, decoding stuff, all those things. So where definitely, based on my experience, there is a I have the capability to add value in that direction as well. And finally, I'm thinking of not finally, pre-finally, let's say. So I'm thinking of coming out with some kind of startup, and finally, to all the faculties and the resource persons. This was really a very good and great effort to steer the quantum mission in India, and finally from that organizer group. So I have never seen in my entire professional career such kind of coordination like Dr. Pilli. So if Nobel Prize would have been there in this thread, so we would have recommended Dr. Pilli for Nobel Prize in coordinating. So that is no language is sufficient, and for all the faculty members, they are doing their best, and I hope and all success for this NQM.
Thank you so much, sir. Thank you so much, and it's a joy actually to have so many senior faculty professionals who are there still wanting to learn and also share. Sometimes I am seeing the interaction sometimes that goes on. Thank you so much. I think Dr. Mustafizur has to take a leave, so let me give him some time to share his. He was the one who was giving a lot of mathematics for us. So yeah, please, Dr. Mustafizur.
Yeah, I mean, I don't have as such anything to say, sir. So first of all, I want to congratulate all the participants. They spent a lot of time and they managed to understand the things, apply the things and all. I'm very sorry, I'm in the airport.
Dr. Mustafizur, we lost your audio. Hello. Ready. Okay. Meanwhile, Dr. Shivansh, are you able to hear me?
Yes, sir, you are audible.
So I'm not, we are not able to hear Dr. Mustafizur, right?
I think there must be some problem with his network at the airport.
Let's check. So Yeah. So yeah, we'll go ahead with the speakers. So I think Dr. Satyaprakash is there. Yeah, I think Devanshu has joined. Devanshu, would you like to share something? Another active member in the group.
Am I audible, sir?
Yes,
Yes,
please.
sir.
Please go ahead, sir.
Okay. Yeah, I mean, I wrote everything over the chat. I mean, whatever I tell will be less considered to the effort and and enthusiasm which the organizing team, the principal investigator, the resources have done. It's a new thing, and I haven't seen in a MOOC. I mean, I haven't been attending MOOC since 2012 when Coursera came live, but I haven't seen MOOC actively working in live sessions at this scale. So this is an experiment. I'm pretty much sure you would be publishing papers of international standards out of it. And that's expected. It's a great success, and it can be possible in India only. I don't think other parts of the world can repeat this at this scale. The only one request is there are Mr. Nandi has just explained, expressed that he would like to go up for a startup, and there are a few like us who would like to go for a part-time research and something of that sort. So if we can provide a constructive guidance in the group and how we can take this up, I think this community will be enlightened for sure. That's all. Thanks for all your efforts and all the active participants here. I'll continue to attend the courses to the extent possible in the future ones as well. Thank you very much, sir.
Thank you. Thank you so much, sir. And we are happy to have senior people like you and, participating, sharing your thoughts. And yeah, we'll try to see what best we can do for starting research. We can try to formulate some problems. Informally, we can collaborate and do research. We'll definitely take that part, right? And yeah, we'll look at some startup ideas also. In fact, Dr. Jay Kumar is part of the startup Anutantra. And there's a faculty in IIT Delhi who has started a startup. So he was there on the World Quantum Day. So we can look at some of the things. Dr. Anindita can help us with some ideas. So let's take it forward. Yeah, thank you so much. So first, maybe Dr. Satyaprakash or Dr. Anandraman. Would you like to say something? Oh, okay. Satyendra Prasad has joined. So in case.
Yes, sir.
Yeah, please go ahead.
Do you need to open video?
Your wish, sir. Yeah, if it's possible, we can see your
audio is fine. Audio is fine.
Yeah, sure.
First, thank you, sir, and you, Emmanuel, sir, and Jadeja, sir, who let me join this course 1 week delay from the first QT-01. Other thing is that my name is Satyendra Prasad. I'm a lecturer in Jyoti Vidyapith, Women University, Jaipur, and I'm physics faculty. So it's not difficult for me to follow up the course, but the programming part was something was difficult for me to follow up. But I am doing that well also. Other thing that I also wish, I'm not saying institute should do, but I'm also wishing that for every lecture, after every lecture, there should be some problem, 1 or 2 problem comprehensively. So after doing problem, we are able to know that, yeah, these things we have to by solving those problems. So I'm expecting from the next session that 1 or 2 problem as assignment, not compulsory, but as a optional. That's the thing. And other thing that just thank you, whole MNIT, sir. Thank you, sir.
Yeah, it's not only MNIT. We had Shivansh Mishra ji from.
Yes, sir. Yeah. More. I would like to give very kind words of you and the Jay Kumar sir and Mustafid sir, who teach very well and very slowly, so that we can follow up his guidelines. So it's very interesting.
Yeah, Thank you.
Thank you, sir.
Yeah, so it's time for speakers now to share their thoughts. So maybe I think Jaykumar sir is there. So let's start with Dr. Jaykumar. Then either Dr. Anand Raman, Mr. Anand Raman or Dr. Satyaprakash can take over.
Good evening to all. Am I audible, sir?
Yes, sir.
Thank you. Thank you. So first of all, I thank Dr. Pilli, sir. In 2021 or 22, I attended course at MNIT just like this. So from there, I started my journey. I attended nearly 150 quantum FDP programs, all related programs. I won't miss any quantum program. Wherever it is happening, I keep on attending. Still also, I am keep on attending CDAC course also. So learning quantum is just like everyday activity to me. Okay. So in the journey, I go along with my friend Dr. Shati Pragas Palanipan. We are friends for past 15 years and we are both learning quantum for past 5 years. Okay. And Mr. Anandaraman is our friend. He is also joined with us. I invited so many speakers to this forum and they gracefully accepted my invite. I thank Anandaraman sir and Satyaprakash sir and of course Mustafur Rahman. I met him personally 2 times and Ritajit Majumdar, we met all together. I thank each and everyone, even the participants. So if you are teaching the participants who are less in our age, it is very easy. But the person who have 30 years of experience and 40 years of experience, who know that field better than us, it is very difficult. So if you are getting some praise from their word, it is truly bliss for us. Okay, thanks for all and thanks for all participants who are very active, encouraging, motivating. We keep learning, we keep growing. Thank you all.
Thank you, Dr. Jaykumar. Thank you. I forgot to mention that you had part of the. But then, if you understand, as much as effort that I put in for QT-03, it was coordinated by Dr. Jaykumar Vaidishankar fully from his side. So 50% we both share. So the speakers fixing, scheduling. If suddenly some speaker didn't come, you know that he stepped in at the last time. So yeah, Mustafizur, quickly, could you complete? Would you say something?
Yes, I'm very sorry. My internet is highly unstable. I'm in the airport. So
Yes.
nothing much. Like I just want to thank everyone for attending this course. You are enjoying it and you are spending a lot of time. So and there is a lot of effort from the government side. Like this week, I just totally spent at Indian Institute of Science ISC to talk to the people and all. And across India, like every institute, every organizations, industry, all the people we are trying to see like which is that question, which is that research area, what is the problem where we can find quantum advantage, right? So this is the right time for the next 5-6 years. So to learn quantum, to take advantage of quantum and lot. And I think the quotes that this institute, MNIT, and especially Professor Pillai sir and the entire team, they are putting a lot of effort for making this educational, not only India, but worldwide now, international program, I would say. And this entire effort of the team is excellent. Thank you for the, thanks a lot.
Thank you.
Yeah, Professor.
Yeah. Go ahead, Dr. Jacob.
This is Satyaprakash.
Yeah, please go ahead, sir.
Yeah. So it was a nice program from May 16 to June 6. Here I wanted to thank AICTE, Ministry of Electronics and Information Technology, IBM Education, and all the joint organizers for the wonderful opportunity. And especially I want to thank all these organizers and who are every day stand out there and executing that, right? So I want to thank them all in person, and I want to congratulate my chief executive officer. It is his tremendous efforts. He works 24/7. Whenever there is an event, he never hesitates. He never asks where. If it is a quantum event, he will be there. So I want to compliment him whenever, wherever required. So it's a nice. I want to thank the team Anutantra and the remaining startups and institutes which were organized to this event. Thank you all.
Good evening, Professor. Yeah. Yeah, this is
And
Anantaraman. Yeah.
yes, sir. And one more thing. Here I want to make one more name. Dr. L. Venkata Subramanian from QCA Quantum Computing India. Special mention and a special thank to him.
Yes, sir. Yeah. Mr. Anandaraman, please go ahead.
Yes, sir. Yeah. So good evening, sir. Very good. Yeah, thanks for the opportunity. So I joined as a participant here, then evolved into a resource person. Thank you for all your support, and so especially for the continuous encouragement of Dr. Jai Kumar for doing this. Otherwise, I will be hesitating to do it. So I have 15 years of experience in HPC. Okay. Then I told, okay, I know only HPC. Quantum, I am just learning. So what I will teach. Then I told, oh, no. Quantum will be part of HPC only. So whatever you know, it is good enough. So then I jumped into it, and so HPC. So I also very much interested now to explore further. So just learning CUDA Q and other things. So in future, quantum will be part of HPC only. So earlier it is CPU, and now it is GPU. Future it will be QPU. So we are very much eager to know. So what type of QPU will be there? How we will integrate into our future HPC? So now we are in the process of installing another 2 HPC also, 100 nodes. So we will explore more in future also, sir. How QPU is integrated in foreign and other things. I am studying it. Yeah. Thank you, sir. Thank you for the opportunity. Yeah. Thank you for Pilli, sir, for continuous motivation, and Jai Kumar. Yeah. Thank you,
Thank
sir.
you. Thank you so much. Yeah, it's a teamwork, and I was also looking at, because we never tried to look at integrating HPC, and of course, as he rightly mentioned, after GPU, it's going to be QPU. I have also started, many people are asking me because they think that I am also a quantum speaker. But I am, so then I started reading on quantum processors. So hopefully I'll be making my few presentations this month. And I'll share whatever I can collect and read, and whatever I put together, I'll share. Anindita ma'am, would you like to say something, or you already taken the lecture? But if you're there, otherwise we'll conclude with Dr. Shivansh.
Hello, sir, can you hear me?
Yes. Yeah.
Yeah, so sir, thank you for this opportunity, and I would also like to thank everybody for their patience. For me, since I've been working in this technology, it gives me immense happiness to have this discussion, which is actually a communication between people who understand the technology and who are going to play a very important role in shaping the landscape of landscape in India. So we have a lot of expectations from you. I know this world is puzzling. It's a little counterintuitive, and trust me, I am involved in this. I know, because I'm supposed to work on technology development, but this is interesting because whenever I study again, with the experiments, I feel that I've learned new. So because of that, I keep pushing myself to to go back to books and then collect. So I'll be happy to work with you, and wish you all the very best, and welcome to the quantum world. Thank you.
Thank you so much, ma'am, and thank you for being part of that syllabus team, which actually motivated this model curriculum. The model curriculum motivated IBM to tie up with AICT academies at various places. National Quantum Mission and AICT coming together. So it was, and that's where Dr. Mani Madhukar, Dr. L. Venkat Subramaniam, and we all should thank Dr. L. Venkat Subramaniam, because he pushed it like anything. I think he said,
Yes.
and then the number started pouring in. I thought some 300, 400, but it is more than 1,000 in each course. So thank you so much
Wow.
for all. Yeah. So we'll conclude with Dr. Shivansh Mishra. Then I'll give vote of thanks, and then we'll close the day. Thank you. Over to Shivansh. Few words.
Thank you, Professor Philly, for providing me with this opportunity and being a part of this great FDP. I thank all the participants who, it was a long FDP, almost 10 days, but you have stuck with it, and it is my distinct pleasure to have with all of you. I thank all the speakers also. So just an interesting tidbit here. This week only, I was giving a session on quantum in another FDP, and Jayakumar sir and Anand Raman sir were speakers there also. So it's a small community where we are doing research in quantum, and it is good to see that more people are taking an interest in this. Thank you, everyone.
Yeah, thank you. And it's a joy for me to conclude this FDP here. Yeah, I think Mustafizur missed the comments. I don't know whether he saw it. Somebody has appreciated, or in fact, also a comment saying that very nice teaching and also very tough questions in quiz 3. So I think that was good. But anyway, yeah, I think we are also increasing the quality. QT-05. One small change, please note and prepare yourself. There will be 50% attendance component. So kindly bear with us. Please attend the sessions. At least half of them are going to be compulsory. So somehow you make, as Dr. Shivansh was saying, 20 days is a big time. But of course, you at least make 10 days out of those 20 days. So please mark your days, plan your schedules, somehow fit in more than 10, listening to more than 20 hours. It will help you. That's what we are pushing you for that. So kindly bear with us. So please be prepared. The quiz is extended till Sunday evening. So no problem, 11:59, you can take it forward. So that is one thing. And secondly, we'll be quiz 2 and quiz 1 is already done. So we are preparing. So I'm just waiting. So I wanted to give the certificates just now by click of an email, but then I just put it on hold. We're just waiting till Monday if I can get the National Quantum Mission certificate. So mostly by Tuesday evening, that is 11th, is it? 10th evening, definitely we'll try to post the certificates to you. Thank you so much. Right? Thank you, Dr. Shivansh, and there are many people who are part of it. We have Dr. Rajiv Arya and also IIT Guwahati and IIT Kanpur people participating here. Thank you all. Thank you, Dr. Jaykumar, for coordinating that whole aspect of putting this content for QT-03 and so many speakers. Now we have varied speakers. We had and everybody was passionate. That's what I would say. Janani or Anand Raman sir or Dr. Satyaprakash, everybody gave their best. And Ashwath, we are missing today, Dr. Ashwath. But yeah, thank you so much. And of course, Dr. Anindita giving from the, what do you say, the creator's perspective, and also giving us an insight from what's going on in the industry and what are the challenges for our country. So with this, we'll conclude. I thank our director, sir, Professor N.P. Padi, who is a big source of encouragement for us to move it forward. And he helps us a lot and gives us guidance. He was there for the first program, if you remember, on QT-01 inaugural. And of course, sometime we may have maybe in the next session, either in the inaugural or the valedictory, we'll have Dr. N.P. Padi to speak to us as well. And then Professor Vineet Sahula, we thank him also for all the support and all the team that works here, Dr. Geeta, Mr. Ramesh, and my student Radha Krishna, who was helpful this time. So because of Radha Krishna, half of my workload has reduced. And thank you so much, Radha Krishna, for being there. And he is doing his MTech. He's about to submit his dissertation on quantum image processing. So we are about to conclude his thesis. Thank you all, and it's a wonderful time of learning. Many people are asking question why you gave June free. Actually, we wanted to have a face-to-face meeting. I'm still working on that. Let's hope. But then we'll definitely meet from July 11th. We'll start the next course, that is QT-05, the actual quantum computing course. So please gear up for that. And then the registrations are open. I've already shared the links with you. You can join. And then each academy will also offer their registration process. You can join with them. So thank you so much. And I wish you all the best. And as quantum, I think Anindita madam made a statement. Wish you all, what do you say, quantum landscape for India. Let's build that big quantum landscape. Thank you so much. Thank you. Anybody would like to say anything? Otherwise, we'll conclude. Thank you. Thank you, Dr. Shivansh, for being there. Yeah.
Sir, I would also like to thank Dr. Vikas because I was, yes.
Correct, correct. Dr. Vikash, tomorrow is his brother's wedding. So
Yes,
that's why he's not able to join. Otherwise, he's in Patna, and then that's their wedding is there. So we are missing him. But then, yeah, he'll be back for the next course. But then, yeah, today he could not join because, no, I think today is the wedding. Today is the wedding. So he's almost about to go for the wedding arrangements.
Yes.
So yeah, I am also waiting for today because today I'll be traveling to meet my family. They are in their parents' place, my wife and daughter. So I'll be joining them today. It's been a wonderful journey with all of you. Thank you so much. So we'll
Happy
conclude.
holidays.
Yeah. I think somebody. Okay, Varsha ma'am, you wanted to say something? Yeah, please go ahead. We'll conclude with this. Varsha Sambaje ma'am.
Yeah,
please.
yes, sir. Thank you so much, sir. Like I just wanted to say that look your happy face every time. So from past 3 months, I'm be like familiar with your face, and it seems to me that it encourages everybody, not only me, everyone in the sessions, speakers, everyone. Wonderful session, sir. Thank you so much. Yeah,
Thank
we'll
you.
miss you, sir. Let's see. In hopefully meet next QT-04.
Bye.
Yeah. Okay. Thank you, sir.
Yeah.
Thank you, everyone.
Thank you all.
Thank you all.